It moves everything. We don't realize the extent to which standards are so important in our technology and our day-to-day lives.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams.
Hello, and welcome back to This Week in Green Software, where we break down what matters in sustainable software. I'm Kate Goldenray. This week, we're talking about a big announcement about leadership transition at the Green Software Foundation, when local AI is actually greener than the cloud, and how to keep observability useful without drowning in telemetry, and a new tool for understanding the embedded impacts of GPUs. Joining me today is Tzviya. Tzviya, will you introduce yourself?
I'm Tzviya Siegman. I am with the W3C. I'm the Director of Sustainability. I am working with my group on the Web Sustainability Guidelines, and I'm always happy to be here.
Great. Once again, happy to have both of us on this, and we've got some great topics ahead of us. So to start us out, I want to talk about the big announcement. So the letter from Asim Hussain, who is the Executive Director of the Green Software Foundation and is stepping down at the end of this month, at the end of March. And he published a really thoughtful look back at what the foundation has accomplished during his tenure and what he's learned along the way. And I'd love to start by looking at some of the project standards and courses that were developed while he was executive director, because this article, just reading it alone, I learned so much about tools that are available, standards that were created, and some really exciting courses. So some of the standards that he mentions that were developed over the past several years was the software carbon intensity model, which many people may be familiar with. And what was interesting is he also discusses how once you build one standard like SCI, you end up getting iterations of it for specific scenarios that may be built on top of it. So after they built SCI, other extensions of it, such as SCI for AI and SCI for web, were then created. And there might be more every year come about after that original advent of SCI. Tzviya, do you know anything about kind of how SCI for web was developed?
So standards is my world. I've been working in standards for more than 15 years, and I do know a little bit about how SCI for web was developed. I also just wanted to call out a phrase that Asim had in there about how standards are kind of like a microcosm of the world. He was delighted to discover that the point about, he said something along the lines of, it's a microcosm of the world. The conversations bring about consensus. And in a way, when you work on standards, you see the best and not quite the worst of society, but you definitely see people at their best and worst. So it's absolutely true. I've led a lot of groups in the W3C and in some other standards organizations where we have to be prepared to make compromises. And we're working on something that, for lack of a better phrase, is for the greater good. And in sustainability, it's absolutely the case. I've worked on things like ebooks, which are important, but they're not about preserving the planet. And with SCI for web, SCI for web, what's fascinating to me and exciting to me is that the work that had already happened on SCI for SCI and then SCI for AI was taken, and there was a desire to expedite the work. So with the group consensus, all of these experts who had been gathered to work on building a metric for measuring emissions for the web, got together and they decided to implement or deploy some AI to work with them. And I don't have I don't have a ton of information about how this was worked on. I've spoken to Chris Adams about this a little bit. But there was a little bit of discourse with some built AI tools, dedicated AI, and they sent a lot of the information to the bot, whatever. I don't know exactly what bot it was. I'm sure Chris would be happy to discuss this with us. Maybe we should interview Chris. And they got a first draft simply by using, not simply, it can't have been a simple process, by using the AI, and then the humans revised that. And they got a first draft out, and they believe it was 3 months. And they worked on Cypher Web, which is not in any way a simple specification. And they have a first draft, and the whole thing came about in under a year. And this will have a huge impact on the work that all of us are doing on sustainability.
So to make sure I understand there, the idea is that you can use AIs to help accelerate the way we can establish consensus in communities by generating a first draft that then can be revised by the community.
Absolutely. And of course, the writing process is often what's most arduous. It might be easy to come up with ideas, but writing a standard is not the easiest process. There's an art and a science to it.
For sure. And there's a lot of voices that need to be consolidated into one piece. And so that makes sense to have this third party do that. And I think that will accelerate the speed at which we can build standards. And one thing that was interesting about Asim's paper or announcement was that it really was almost a love letter to standards. He starts by saying, I was skeptical about the power of standards. And at the end, I just want to read this quote that he kind of concludes with. If you want to shift money, resources, and funding into areas that matter, working on standards is one of the most powerful things you can do. You can change the world with a conversation. It's powerful and it's a poetic line, and it makes me want to go find a standard to work on. I do some standards work in the WebAssembly space, which is defining technology, but one of the great things about the Green Software Foundation is it's an open invite. They have working groups where you can be a part of various standards that are being developed. So hopefully this announcement leads other people to look to have impact through standards, which policy can be built on top of and technology can be built on top of.
Absolutely. I mean, like I said, I've been working in standards for 15 years now. One of the things that has drawn me to standards for so many years, and I can't say this without putting in a pitch for joining the W3C, and feel free to reach out to me, what interests you, is exactly that. It moves everything. We don't realize the extent to which standards are so important in our technology, in our day-to-day lives. Think about the relatively recent policy change about USB-C. So it used to be that we'd have different chargers for everything in life. And in the EU, everything, our phones, our computers, everything. In the EU, they made a policy change about standardizing USB-C. And that has a ripple effect on all of our technology. And I no longer need different chargers for everything in my house, and I'm not in the EU. So one piece of legislation in the EU, which effectively standardizes things, causes a ripple effect in standards. And I talk about this regularly, the kind of cyclical effect of legislation, regulation, and standards on each other. So I'm working on the Web Sustainability Guidelines, which is guidelines about how to build the web in a sustainable way. And we look at policy, and policy looks at us, and we affect one another. And with standards, you often have a beautiful combination of large technology companies, startups, regulators, academics, and it's really remarkable to have all of these people generally in a royalty-free setting where they can all work on things together and come to consensus about really generally very complicated issues.
Especially on issues that have a commons, kind of like the web, building standards there to make it a better commons for everyone.
I think it's also worth noting some of the other things that happened during Asim's tenure. There's courses and some of the metrics that are available. Kate, did you want to comment on some of the courses? Well,
yeah, I read this article and immediately want to spend a whole weekend with a cup of coffee and a few courses. One of them I hadn't heard of was the Green Software for Practitioners course from the Green Software Foundation, which has over 130,000 completions. I would like to add some numbers to that with myself. And I know you know some other courses, Tzviya, that might be useful to other people.
Yeah, there are a few different courses available in the green space. And I'm sure I'm leaving some out. And, let us know what we've left out. Come tell us about your training courses. But OPF 1.5 has a course for organizations. They target it to businesses to help make it sustainable. And they'll they'll work on preparing the leadership as well as the technologists. Green Pixie, which is a green hosting solution, has, I forgot what they call it, it's a green ops course. I've taken that one, and I also have not yet taken the Green Software Foundations course, and clearly Kate and I need to do some homework.
Yeah, I'm excited to come back a better practitioner after all of these courses. This letter from Asim is a goodbye letter. And so I think it's a good moment to talk about, what can this next era of the Green Software Foundation look like? And what should the Green Software Foundation double down on? Should it be more standards, more tooling, more training, more policy engagement, or a broader community? Because he also talks about the community that they built during his time at the Green Software Foundation. In your perspective, Tzviya, which one would you like more of and for the next 5 to 10 years?
I guess my answer can't be all of it. I love the Green Software community, the GSF community. I work with so many people from GSF, but I would really love to see more of GSF in North America. Sci for web and AI is not as much of a household name here as it is in Europe. I know that in North America, our political climate is not as welcoming, but there's absolutely interest more from a grassroots level, more from the developer perspective. And I think that we absolutely could build a similar community here, and we would love to be more involved here in North America.
Yeah, and I think another thing I would mention is maybe more partnership with research and universities. We've talked on this podcast with a lot of researchers about a lot of researchers putting out papers on sometimes the carbon intensity of AI, like we'll talk about a little later in this episode. And it'd be interesting to also build the bridge there between general consumers of tech and software engineers and policymakers with some of those researchers. I don't know if that's within the purview of the Green Software Foundation, but especially American researchers, because like you mentioned, a lot of them are European. And so maybe there's a way to accelerate some of that research here in the US as well.
That would be great to see. And I think that we just should say a big thank you to Asim for all that he's done, and also for, bringing us here.
For sure. He even mentions Environment Variables podcast in This Week in Green Software. And that was something that he also helped build up. And he talks a lot in that article about, have faith, keep trying. And it took them a while to ramp up this podcast, and it got to where it is today through that patience and careful hand.
Yeah. And we'll miss you, Asim. It's been a pleasure working with you.
For sure.
We can't wait to see what happens next.
Yes, we're staying tuned in. Okay, let's go ahead and move on to our next topic. And that is an article from Intelligent Living titled, taking a deep breath here, When is Local AI Greener Than the Cloud? How Personal AI PCs Could Shift Emissions and E-Waste into Your Zip Code. And it really pushes back on the simplistic idea that local is always greener or the cloud is always greener for AI workloads, and argues that it depends. So it depends on many factors like grid carbon intensity, utilization rates, hardware lifespan, and whether waste from heat can be reused. And it also depends on what you're comparing it against. So the scenario, is it an always on local box that you're running, or is it a spiky cloud workload? So the key takeaway of the piece is that that location is only one variable, and rather wherever you're running this, it's the operational profile and the embodied impacts that often dominate the result.
I have to say, it's really hard for me to wrap my brain around one solid takeaway from an article like this. The biggest point for me is that embodied emissions matter sometimes more than peak watts. So there was a quote in there highlighting why device lifespan and upgrade cadence matter as much as watts. And so we have a scenario where a startup runs a workstation constantly for 3 months and then leaves it idle for 9 months, demonstrating how climate impact shifts with the compute efficiency to idle, draw, and replacement timing. And this goes back to a few of the conversations we've had in the past. Things like measuring down to the screws, and things like the location mattering, but sometimes location is difficult to figure out. Is it the rain? Is it the solar? And every conversation we have about this seems to come down to it depends. And so the question that I have with so many of these is, what is the conclusion that we can draw? And maybe you have some answers, Kate.
Maybe not an answer, but I do think there's maybe a checklist you can make for yourself on whether to run something locally or in the cloud. And it's not it's nothing new here, but what I got from the article was that one, you want to pick the cleanest location. So it talks about electricity maps. That's a great resource, electricitymaps.com, where you can look at what is the grid that you're on locally. I'm in Seattle, so our grid is a lot of hydro and it's quite green. So for me, that would be a checklist, a check on that. The second would be, when are you running this? So don't keep your local server on all the time. Idle power pool is not what we want. Rather, run only when the grid is not otherwise being utilized. And the article talks about the difference between marginal versus average carbon intensity. If you're thinking about when to run it, think about average carbon intensity, not marginal. And the idea there is that when you talk about marginal carbon intensity, you're talking about, if I turn on my server, what will be the additional energy that the grid needs to add? And oftentimes added sources of energy are carbon intensive. So maybe gas, because they're going beyond the average demand. It's better to talk about the average because that is what is the overall cleanness of your grid. Kind of a tangent there, but for me, that would maybe mean running maybe a workload in the middle of the night when people aren't working from home. Certainly not before the workday or right after the workday when people are charging their electric vehicles, turning on all their houses, turning on their stoves, their microwaves, etc. And then, so that's the second one. So maybe I would choose to run it in the middle of the night if it's some background process. The third one is extend the hardware life. So if I'm getting some sort of server for a specific thing, maybe get something that's used instead of buying a new piece of hardware, or share it with other people. Maybe you can, use Tailscale and I'll give more people access to your one piece of hardware and share it with other people and segment it. I don't know, have fun with that potentially. And the fourth one would be, like I mentioned at the start, turn off your server. Would you like you would turn off your lights? And that would kind of be the checklist I would keep in mind. The other thing that is a big point that it mentioned is using the externality of heat of these servers. University campuses do a really good job of this sometimes, where they have their own local server setup, because they can actually sometimes use the heat from those servers to heat the buildings on campus. And so you probably can't set that up in your own home, but we should be encouraging campuses to continue to do that. And that might be a way to make local servers on campuses actually more sustainable than campuses using the cloud.
That's really smart. I should set up a server in this room because it's always freezing.
I was thinking about that. I do have a space heater behind me because we don't always heat our house. So I don't know if my little server is providing enough heat for that, but that would be a nice effect.
All right. Really interesting. All right. Our next article is about the green side of observability, why less data can mean more insight. This article makes a strong case that observability can become a sustainability problem. Not because observability is bad, but because telemetry bloat is easy to create and hard to roll back. It highlights strategies like reducing high cardinality metrics, tightening retention, aggregation at ingestion, sampling intelligently, and being deliberate about what you collect versus what you can derive. The nice framing here is that better observability often means more intent, not more data. Kate, I'm going to leave this to you because this is your expertise.
I really like this article because I think we can it mentions how there can be alignment on good observability and better sustainability. And I think I've experienced that through some of the platforms I've built. And I think there's good incentives to be better about this. So it talks about if you have too many metrics you're capturing or too high of cardinality, sometimes you don't have as intelligent of alerts, and you get fatigue as someone who's responding to these alerts because there's too many. So that's one. The other is it talks about sampling. So the idea of that is that instead of sending absolutely every trace or metric to a centralized server, you only send a sample of them. So that way you're only storing a sample of all of the data instead of all of it. So that reduces the data you're storing. And that actually reduces the cost of your bill. So there's incentives there on the operations side to do that align with the sustainability incentives of reducing data collection, which I think is interesting. And that's something that we implemented. There's a tool called Refinery that Honeycomb has put out that does a really good job of this. So say you have a platform that receives a bunch of requests, you can still get a total request count, but choose to only always send errors. So that you can still get a more focused lens into when errors are occurring, but you only send a sampling of the successful responses, stuff like that you can drill into. And another one that it mentions is aggregation at ingestion, and how that can actually help improve performance. So say you capture a metric for every time a certain thing happens on your platform. That is, you're sending a data every single time something happens, which actually adds latency. So if instead you locally aggregate and send once, you're going to have a more performant platform. So that's another example of something that improves your platform, and it makes it more sustainable. So it's a really cool article to read, and it has some checklists that you can maybe work through. And another thing it mentions is open telemetry, which is a standardized set of observability APIs that you can point to so that you can always change your mind what the backend is. And that provides opportunities to use things that are more fully featured that can help you make some more sustainable choices and not be tied into one solution, which is always a great thing to have on the engineering side.
So if I'm understanding things correctly, something that I might be able to implement today to cut emissions is the aggregation process, which actually just sounds like something logical to do, because why would I want ping, 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 ping when I could just get one ping? It's almost like, putting this in very simple terms, getting a digest instead of getting 4,000 emails.
Exactly.
So it's just about efficiency. Forget about sustainability for a moment. Why want to be bothered all the time?
There are some downsides to that, though. Sometimes the metric you're capturing can't be aggregated. It might not be something that you can continue to aggregate each time and then push one aggregated sum. So it's really good for counters, but there are some things that you can't aggregate as easily. So there's always those trade-offs.
Of course.
Well, let's go ahead and move on to our final piece. This is on, it's a calculator that actually shows you the embedded or impacts of your GPU that you may be using. And so it's data.hublot.org/GPU. And if you go there, you can actually choose which graphics card you're using. So whether that's a NVIDIA A100, NVIDIA L4, and it'll show you how much fossil fuel resources, global warming potential, and mineral depletion that GPU causes. And then it'll put it in equivalents, which I really like. So the liters of crude oil that it depletes in fossil terms, the amount of kilometers that a car would have to drive to have equivalent global warming potential, and the kilograms of copper so you can really actually visualize what the impact is of that processing card. And it really focuses on something that green software teams often miss, which is those embodied emissions of hardware, which is something we've talked a lot about in this episode. And it's really important to think about right now because AI is accelerating. And so the amount of compute we need is ramping up. And it's a timely reminder that optimization isn't just about runtime efficiency and that hardware choices matter. And specifically what kind of hardware you choose to use makes a difference.
Yeah. We mentioned earlier, like you just said, that embodied emissions are one of the most important, if not the most important thing to consider. I found myself wondering who the target user for this calculator is, though. I would love to see something like this that could be applied at scale. So let's say a purchasing manager who's trained in green software purchasing, something along those lines, or maybe the sustainability manager for an organization. It's possible I'm not exactly understanding how this is to be applied, but I'm just a little bit skeptical about the individual application of this to, maybe if I'm buying a phone as somebody who's in the sustainability space, I could understand this. But while I love this and I love the visuals of this, I have a little bit of doubt about the real world application. What do you think?
Yeah, I agree. I, as a engineer at a large company, cannot choose what GPUs that company chooses to procure. But I do think it provides visibility into numbers that make us more aware, and maybe would make me ask what chip we're using. I don't know. So that starts my own questioning there, and that's certainly a start. I think also looking at this resource, the numbers, if people are curious, is based off of a model that was developed as a part of a paper published at the end of 2025 called More Than Carbon Cradle to Grave Environmental Impacts of Gen AI Training on the NVIDIA A100 GPU. And that same author, or I know at least Sophia Falk from it, also wrote a paper that came out a couple months later that we've talked about in a previous episode called, let me remind myself, From Flops to Footprints, the Resource Costs of Artificial Intelligence, which was where in the paper they discuss basically, how resource intensive each AI model was using the NVIDIA A100 GPU as the baseline embodied emission. So it talks about how resource intensive it was to train each model based on having had that calculation of how intensive the embodied emissions were of that GPU. And so just having these numbers enables so much more research to happen on top of it about how resource intensive other factors are, not just the calculator.
Got it. That makes a lot of sense. I think one of the other authors, if I remember correctly, was Dr. Sasha Lucchini, and her name probably comes up in every episode. A lot of the research about AI emissions comes from her. And I think just won an award this week. I can find what it was, but I saw something on LinkedIn about her being awarded something in Quebec.
Oh, okay. While you're looking that up, I think another thing that I was thinking about when we were talking about who is the consumer of this calculator was about some of the way GPU procurement happens, maybe before you're even able to assess the embodied emissions of that GPU, even before that GPU is available to researchers. It would be nice if we could know, what the embodied emissions are of a GPU before the contract is signed to acquire X amount of them in 2 years. Because from my understanding, some of these contracts are signed before even the GPU's finished. I'm taking a pause to see if you want to.
I'm sorry.
Found.
It's all in French.
Oh. I'll mention for folks, if you want to dig deeper into the research behind the calculator and some of the report, there is a full report. It is entirely in French. I can read some French, but I didn't have the gumption to read 25 pages of French. But if anyone feels like reading it, maybe you could share a summary with us. And it goes into more of the details of the numbers and the how they calculated the embodied emissions.
It looks like Dr. Sasha Lucchini has won an award there's an article in French that I've seen on LinkedIn. Laureate category Femme Engagée de la Relève. I'm not sure exactly what that means, and I'm sure my French pronunciation is just terrible. But congratulations, Dr. Sasha.
I'm excited to try and read that very slowly. And what we can link in the show notes if people are curious more about the details of the award. But many congratulations going around in this episode. With that, I would like to wrap us up with a list of some upcoming events for the next couple weeks. So first up, hobby projects to green production systems in Budapest on March 31st at 6 p.m. So this is a part of a green software meetup in Budapest, basically letting people get hands-on with how to have a hobby project, and goes through an engineer's personal journey with playing around with that hobbyist setup and how to do it in a way that's environmentally responsible. The next event coming up is on April 7th at 6:30 p.m. CEST in Karlsruhe, Germany. I'm not sure the pronunciation of that city, but it's a Powered BI dashboard workshop, and it helps people understand how to make a clear overview of how to capture emissions from several major hyperscalers, on-premise data centers, and other sources, and how to create one visualization for all of that. So very interesting workshop. And then finally, April 14th and 15th in Singapore is Green I/O there. And Green I/O is a great series of conferences across the world with a lot of speakers coming in and talking about green software topics. So highly recommend, if that's in your area, to check it out. There's also other Green I/O instances, so you can see if there's one happening closer to you. With that, that's the end of our this week's This Week in Green Software. So big thanks to Tzviya and Asim once again for all the work you've done with the Green Software Foundation. If you're working on green software and want us to cover a resource, a tool, or an event in a future episode, please send it our way via the links in the show notes. And as a final reminder, all the resources for this episode are in the show description below, and you can visit podcast.greensoftware.foundation to listen to more episodes of Environment Variables. We'll see you all in the next episode. Bye for now.
Bye.
Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show, and of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.